Hello kids, so this is part 2 of the chapter number system. We will start with example 11. Now I'll just read the example. It says that visualize the representation of 5.3 bar 7 on the number line up to 5 decimal place. Yes, so in the question they say you want to visualize 5.3 bar 7 on the number line up to 5 decimal places. Up to 5 decimal places, 5.3 bar 7 would be 5.37. This is the number. You have to represent this number. Firstly, this number will lie between which two integers? So you know it is greater than 5 but less than 6. So it will lie between 5 and 6. So in the step 1, construct a number line from 0 to 10. 0, 1, so step 1. Now we know this number will lie between 5 and 6. So what we are going to do in the next step, we are going to zoom the region between 5 and 6. Now we are going to write this number in 1 decimal place. So 5 in 1 decimal place would be 5.0. The next number would be 5.1, 5.2, 5.3, 5.4, 5.5, 5.6, 5.7, 5.8, 5.9, and this is 6. So now we have zoomed the region between 5 and 6. Now you have 5.37. 5.37 will be greater than 5.3 but less than 5.4. So what we are going to do, we are going to zoom the region between 5.3 and 5.4. So let's construct a third number line. This is your 5.3. Now write the numbers between 5.3 and 5.4 up to 2 decimal place. So 5.3 will be 5.30. Then you would have 5.31, 5.32, 5.33, 5.34, 5.35, 5.36, 5.37, 5.38, 5.39 and 5.40. This is your 5.4. So you have zoomed the region between 5.3 and 5.4. Now 5.377. So we know 5.377 will be greater than 5.37 and less than 5.38. So in the next step, construct a new number line and we are going to zoom the region between 5.37 and 5.38. So 5.37 in 3 decimal place would be 5.370. The next number would be 5.371. Then 5.372, 5.373, 5.374, 5.375, 5.376, 5.377, 5.378, 5.379 and last 5.380. This is 38. So this is 3 decimal place. We have to go up to 5 decimal place. Now 5.3777 would be greater than 5.377 and less than 5.378. So let's construct a new number line. and we will zoom the region between 5.377 and 5.378. So this would be in 4 decimal place 5.3770. This would be 5.3771, 5.3772, 5.3773, 5.3774, 5.3775, 5.3776, 5.3777, 5.3778, 5.3779, and last 5.380. This is your 5.3780. So this is up to 4 decimal place. Now the next number line would have numbers having 5 decimal place, and that would be our final step. So construct the last number line. This number would be greater than 5.3777. So it is this number. So this is 5.37770. The next number would be 5.37771. Then 5.37772. 5.37773, 5.37774, 5.37775, 5.37776, 5.37778, 5.37779, and last 5.37780. So your required number, we missed, this is 777, this would be 8, then you have 5.37779, and last 5.37780. So your required number is this. So this is how you would be representing the number up to 5 decimal places on the number line. That was example 11. Then you have exercise 1.4, which comprises of 2 sums similar to this. We are not taking that. Now we will move to example 12. What is example 12? In example 12, they have given us some numbers. We just have to comment whether they are irrational numbers or not. The first number is 7 root 5. We know root 5 is irrational, therefore 7 root 5 would be irrational. The next 7 upon root 5, again the same concept. As root 5 is irrational, therefore 7 upon root 5 will also be irrational. The third number that they have given is root 2 plus 21. 21 is rational, root 2 is irrational, therefore root 2 plus 21 is irrational. The last number that they have given is pi minus 2. 2 is rational, but pi is irrational, therefore pi minus 2 will also be irrational. That is example 12, sorry. Now we will take example 13. In example 13, they have asked us to add 2 root 2 plus 5 root 3 and 2 minus 3 root 3. So we have to add these two numbers. So in our solution, 2 root 3 plus 5 root 3, this is the first number. Then I kept a positive addition sign, and you have to add this to root 2 minus 3 root 3. Now look for like irrational terms. There is some mistake here. This is 2 root 2. Look for like irrational term. This is also root 2 term, this is also root 2 term, so they are like irrational term. This is, how many times root 2 you have here? You have 2 times, and over here you have 1 time. 2 times plus 1 time makes it 3 times root 2. Now these two are like irrational term. This is also root 3, this is also root 3. Over here you have 5 times root 3. Here you have minus 3 times root 3. What is 5 minus 3? 2. So this will be 2 times root 3. That was example 13. In example 14, we have to multiply 6 root 5 by 2 root 5. You have to multiply this two. On multiplication, 6 root 5 and 2 root 5. How do we multiply them? You will be multiplying the rational and rational terms. So what is 6 into 2? 12. And multiply the irrational and irrational part. What is root 5 into root 5? Root 5 into root 5 is root 25. 5 into 5 is 25. So it is root 25. And we know root of 25 is 5. So your answer is 12 into 5, 60. That was example 14. Now let's take example 15. What is example 15? In example 15 we have to divide. We have to divide 8 root 15 by 2 root 3. So 8 root 15 divided by 2 root 3. We will follow the same approach. You will divide the rational and irrational. So we know root 15. 15 is 5 into 3. As 15 is 5 into 3, you can write root 15 as root 5 into root 3. And denominator you have 2 root 3. The root 3 term gets cancelled. 2 ones are 2 fours are. Your answer will be 4 root 5. That was example 15. Now, the next concept is to construct irrational number on the number line. But we have already seen that in the first part. We saw how to construct root 2, root 3, root 5 on the number line. But what if you have to construct irrational numbers in which the digits in the root are not integers, they are decimals? Like what if you have to construct root 7.5 on the number line? What if you have to construct root 8.7, root 9.8? So what is the approach? So let's study that very important part. Let's say you have to construct root x on the number line, where x is any number in decimal form. X can be 7.5, 8.5, 9.2, anything. So step 1. In step 1, what you do, construct a line segment AB of length x plus 1. That is, if x here is 7.5, AB would be 8.5. X is 8.3, AB would be 9.3. So step 1, construct AB. What would be the length of AB? AB would be x plus 1 units. Step 2, mark BC on AB such that BC equals to 1. Once you have constructed AB, then mark C on AB such that BC is 1. Step 3, locate the midpoint of AB. Yes, so O is the midpoint of AB. Now how to locate midpoint of AB? You know how to construct perpendicular bisector. What we do is, take more than half of AB, draw an arc, And with that same radius, take B as center and cut this arc. Now the line passing through these 2 points would be your midpoint of AB. So this is how you will locate the midpoint of AB. Next step, because OA is the midpoint, now take O as center and radius OA. Take O as center and radius OA and draw a semicircle passing through A and B. In the next step, construct CD perpendicular to AB. So this CD will be equal to root x. Now, if let's say C is the origin, let's say this is 0, and you want to locate root x on the number line. In the final step, take C as center and CD as radius and draw an arc. So CD will be equal to CP. CD is root x, so this point will represent root x. So this is how you will construct irrational numbers in which the irrational number is in decimal form on the number line. This again is a very important topic. You should be very thorough with this. Now let's take example 16. What is example 16? In example 16 we have to simplify. The first question to simplify is 5 plus root 7 into 2 plus root 5. We have to open the brackets. Excuse me. So we have to simplify. We are going to multiply this 2. So let's open the bracket. So first step 1, first multiply 5 to this bracket, and then you will multiply plus root 7 to the bracket. So now when you open the bracket, 5 into 2 is 10, 5 into root 5 is 5 root 5, plus root 7 into 2 is 2 root 7, and root 7 into root 5. 7 into 5 is 35, so this will be root 35. Do we have any like terms? No. This is rational and these 3 terms are irrational, but this is root 5, this is root 7, and this is root 35. So you cannot add them. So that will be your final value after simplifying. The second question. In the second question, they have asked us to multiply 5 plus root 5 and 5 minus root 5. When we look at this 2 bracket, we observe they are in the form of a plus b, a minus b. We know a plus b into a minus b is a square minus b square. A plus b into a minus b is a square minus b square. So we will be using this identity. So you will write this as a is 5, a square, minus b is root 5, b square. What is 5 square? 25. What is root 5 square? 5. What is 25 minus 5? 20. So this will be your answer. Now the third question. In the third question, they have asked us to expand root 3 plus root 7 whole square. So we can observe it is in the form of a plus b whole square. We know a plus b whole square is a square plus 2ab plus b square. So root 3 plus root 7 whole square would be, our a is root 3, a square, plus 2, a is root 3 and b is root 7. So this is 2ab plus b square, b square. Now we know the square of root 3 would be 3. This is 2. Root 3 into root 7. Both are irrational terms. You can multiply 3 into 7 is 21. So this is root 21. and root 7 square is 7. 3 plus 7 is 10 and this is 2 root 21. This will be your answer. The fourth question in example 16 is root 11 minus root 7 root 11 plus root 7. So we can observe it is again in the form of a minus b, a plus b, and we know a minus b, a plus b is a square minus b square. What is root 11 square? 11. What is root 7 square? 7. 11 minus 7 is 4. So that was example 16. Now let's take example 17. In example 17, they have given us an irrational term 1 by root 2. And the question reads as rationalize the denominator. Now if you look at this irrational term, the numerator is 1. We know 1 is a rational term. The denominator is root 2. Root 2 is irrational. And the question is asking us to rationalize the denominator. What does that mean? It means that we have to make the denominator rational. Here the denominator is irrational and we should make it rational. So now if you have root 2, which is the smallest factor that you will multiply with root 2 to make it rational. So we know root 2 into root 2 is 2. So if you multiply root 2 to root 2, it will become 2 because root 2 into root 2 is 2. So to make it rational, we have to multiply root 2 to this term. But we know we cannot multiply root 2 only to the denominator. So we are going to multiply root 2 in the numerator and denominator. And in the bracket you should write multiply numerator and denominator by root 2. So now when you multiply, what is 1 into root 2? Root 2. And what is root 2 into root 2? 2. So now the denominator is rational. So the question ends here. Now let's take example 18. In example 18, they have given us 1 by 2 plus root 3. Again you observe that numerator is rational but the denominator is irrational. And they have asked us to make the denominator rational. So similar question, the only difference over here the denominator had only one term. Here the denominator is of the form a plus b. If you have only one term in the denominator, always remember you multiply with that same irrational term. We had root 2, so we multiplied it with root 2. But here if you have the number in the form of a plus b, if the denominator is of the form of a plus b and if you want to make the denominator rational, keep in mind you have to, if they have given number in the form of a plus b, you will multiply a minus b. That is, if they have given 2 plus root 3, you are going to multiply it with 2 minus root 3. So if this is 1 by 2 plus root 3, so we know we cannot multiply 2 minus root 3 only to the denominator. So you are going to multiply it to the numerator as well as denominator. Here write in the bracket what is the step? So multiplying numerator and denominator by 2 minus root 3. Now with the numerator 1 into 2 minus root 3 is 2 minus root 3 and the denominator, these two brackets are in the form of a plus b, a minus b, which would be a square minus b square. Now numerator would remain 2 minus root 3. What is the square of 2? 4. And what is the square of root 3? It would be 3. What is 4 minus 3? 1. So you write this as 2 minus root 3. No need to write the 1, but in the denominator as you have 1, We know the denominator is rational. So the sum ends there. That was example 18. Now let's take example 19. In example 19, the question is 5 by root 3 minus root 5. Similar question, you have to make the denominator rational. You observe that the denominator is in the form of a minus b. So you will multiply a plus b to the numerator and denominator. So as you have root 3 minus root 5, you are going to multiply root 3 plus root 5 to the numerator and denominator. Write the result in the bracket. You will write multiply numerator and denominator by root 3 plus root 5. Now in the numerator this will be 5 into this. So 5 into root 3 plus root 5. But in the denominator it is a minus b, a plus b, and we know a minus b into a plus b is a square minus b square. So this is 5 times root 3 plus root 5. Root 3 square is 3, root 5 square is 5. 3 minus 5 is minus 2. Minus 2, I place the minus sign in the numerator, and in the denominator minus 2, this is the minus sign and this is the 2. This is your answer. This is the solution for example 19. Now let's take example 20. Example 20. In example 20, they have asked us to rationalize the denominator of 1 by 7 plus 3 root 2. We observe that the denominator is in the form of a plus b. Now because we have a plus b in the denominator, we will multiply a minus b to the numerator and denominator. We know the reason to write. The reason that you will write is multiply numerator and denominator by 7 minus 3 root 2. Now 1 into 7 minus 3 root 2 is 7 minus 3 root 2. Denominator is a plus b, a minus b, which is a square minus b square. The numerator is 7 minus 3 root 2. 7 square is 49. What is the square of 3 root 2? What is 3 square? 3 square is 9. What is root 2 square? Root 2 square is 2. What is 9 into 2? 18. The last step, this is 7 minus 3 root 2 and 49 minus 18 is 31. That is where you make the denominator rational. Now we will be taking example 21. Again we have to simplify. The first question is 2 to the power 2 by 3 into 2 raised to 1 by 3. We observe that the bases are same. If bases are same in multiplication relation, what we do is we add the power. So you can write this as 2 raised to 2 by 3 plus 1 by 3. Now what is the LCM of 3? 3 in the denominator, LCM is 3. So in the numerator you will write 2 plus 1. So this is 3 by 3 and 3 by 3 is 1. So your answer is 2. This was first sum. In the second sum, they have given us 3 raised to 1 by 5 whole raised to 4. If there is a bracket sign, you straight away multiply 1 by 5 and 4. So this will become 3 raised to 4 by 5. Always remember this concept. Let's say if it would have been 2 square and bracket 3. You multiply 2 and 3 and you write this as 2 raised to 6. But if there would have been no bracket, if there is no bracket, this means 2 cube, and you write 2 raised to 8. Now as there was a bracket here, we multiplied 1 by 5 and 4 and we got 4 by 5. In the third sum it is 7 raised to 1 by 5 divided by 7 raised to 1 by 3. In multiplication what we do is we add the power, in division we subtract the power. So it will be 1 by 5 minus 1 by 3. Now what is the LCM of 5 and 3? The LCM of 5 and 3 is 15. 5 into 3 is 15. 1 into 3 will be 3. 3 into 5 is 15. 1 into 5 is 5. 3 minus 5 is minus 2. So you write your answer as 7 raised to minus 2 by 15. Now the last sum, the fourth sum, it is 13 raised to 1 by 5 into 17 raised to 1 by 5. Now here the base is not same, but the power is same, and the relation is multiplication relation. So what you can do is, you can write 13 into 17, use the bracket and write a common power. You can multiply 13 and 17, this comes to 221 raised to 1 by 5. So that completes the chapter. I suppose with this you should be able to do the exercises which I haven't taken, and I personally feel you will not find any problem in solving first chapter from the textbook. Thank you.